My work is about the expansion history of the universe. The results that I will talk about today are coming from a survey from DESI, the Dark Energy Spectroscopic Instrument. This is a survey that collected 6.5 million objects, galaxies, quasars, and so forth. In 5 years, we will collect about 40 million galaxies. But using this 6.5 million of galaxies and quasars, we were able to map 11 billion years of the expansion history of the universe. The expansion of the universe is not a mystery, because that's something we know for the last 100 years at least. However, the fact that the expansion of the universe is accelerating, that is a mystery. In fact, in 1998, the discovery of cosmic acceleration brought a Nobel Prize. However, for the last 25 years, we don't know what is causing this cosmic acceleration. The theory of Einstein, it can predict that the universe is either expanding or contracting. However, the cosmic acceleration itself, we don't know. DESI and the research that we did allowed us to find some hints that some properties. So we talk about cosmic acceleration, and there is a kind of energy called the dark energy that if it is put into the equation of gravity of Einstein, it can cause the acceleration. So mathematically, it's not a problem. However, physically, what is dark energy? That's something we don't know. And the work from DESI allowed us to pin down one characteristic of this dark energy. It is a property that compares the pressure and the energy density of dark energy. And what we found out for the last 25 years, we thought that this ratio is a constant. However, with DESI, we discovered that it is not constant. So if this finding, this discovery persists, and if the evidence for it grows, this is a huge for the question of cosmic acceleration. So DESI was conceived and was built and was conducted with the goal to understand cosmic acceleration. And then there are 72 institutions. It counts a lot of big universities, a lot of about 900 people working on DESI. And the goal is to try to understand dark energy, cosmic acceleration. That's the big mystery that DESI is trying to understand. So again, the discovery is to find that this property called the equation of state of dark energy is not constant in time, it's varying in time. So if it's varying in time, it gives us a break, because then we can track it down and find what it is. But what we were before, we were stuck with a constant value of -1, and which is not really a solution. It was more a problem than a solution. But now the door is open, so already our results, a lot of people are trying to interpret, to find this, to use our results to track down exactly what dark energy is. So are we are working on it. I have been working on this problem of cosmic acceleration for 2 decades. For me, it came as when we used the data, we saw the real data in December, we unblinded this data, I saw right away that something was out of the ordinary. So the excitement started, and for me, it was like, it started being like a dream coming true. I did not think that we will make such a finding or something like this about dark energy, whether from DESI or another thing, will come out in my lifetime. The gift is that I presented these results for the first time at the American Physical Society meeting. So that was really, again, something that I was very delighted, very pleased with. 100 years ago, we understood the theory of Einstein, that's what is the theory of gravity. At the time, nobody would have thought that today, if we don't use general relativity of Einstein, and if we don't put it into our GPS, the GPS will be off by 15 kilometers, 10 miles every day. So in the same way, understanding the theory of gravity and how the universe works and the gravity works around us better than the theory of Einstein will maybe in some years prove to be as important as the GPS is important for us today. So in other words, scientific discoveries, not only they are exciting, but they will always have consequences on our lives. We are on this planet of Earth, which is a tiny piece in the entire universe, but we do understand almost the entirety of the universe. That, first of all, is a fascinating thing, but also practical things come after, and they come after in a big way.